Thank you very much for coming. I'm just making sure I'm in the right place. Adair's just giving me instructions for where to stand. You know, in other things they would have a cross on the floor, you know, be here, but not here. So I'm John Loughran, I'm the Dean of the Faculty of Education, and it's my absolute pleasure to have the opportunity to introduce Professor Helen Forgaz tonight to do the first of the Dean's lectures for this year. And I just need to tell you a couple of little things about Helen. Not so much the academic, she wouldn't be a professor if she wasn't an outstanding academic, but you need some of the inside stuff on what she's like. So Helen, just sit back and relax for a minute. Helen and I actually started here at the same time, about in 2001, I think, when we were 1989. And you go back to 1989 and we were both actually relatively fresh out of school as teachers. And we pulled the short straw on a number of jobs that had to be done in the faculty. And this is sort of what happens in academia, but it's called proving yourself. And so what Helen and I were involved in was a program of a large number of Filipino educators, tertiary educators, who were coming here to get a PhD or to start on a PhD track, and we were two of the people that were involved in helping them with this project and doing some teaching. Now, fortunately, they were all physics teachers, and so I immediately became redundant. But Helen, as a physics math person, was in the middle of this to begin with. Now, one of the things that happens in these testing times when you're beginning in academia is everybody is looking to see how you perform. I was moved to the side relatively quickly, and Helen was moved to the middle, to the centre stage of the PASMEP project, and she was put there for what are obvious reasons. She was an outstanding teacher, she was an excellent communicator, she was loved by her students and everybody that she worked with, and she did something that really, really matters in tertiary education. She was reliable, she did things on time, she never kept anybody waiting, and everything she did was at an exceptionally high standard. Those things underpin what Helen is as an academic and as a scholar. Now, the other thing, who in the room has been to New York? Who's been invited to the United Nations? I think someone's got a hand up for that. How cool is it to have somebody who's actually been invited to the United Nations? Now, I would like to say that she presented to the president, but she had to deal with the underlings of that time, people around really important topics and issues. She didn't have Obama or Clinton or Reagan or whatever, but in their place, they had Helen. How cool is that? And tonight, Helen, it's absolutely a pleasure to have you as a professor and a presenter. I pass to you the magic microphone that goes with the video, and I look forward, as everybody does, to one of your wonderful presentations that will bring us into understanding her work, her ideas, and the stuff that's made her famous in the world of academia. Helen, welcome.
Thank you. Oh, John's given me a lot to live up to, I think, but here we go. I want you to have a look very carefully at the images on this particular slide, because they were very carefully selected. Australia's been a federation for over 100 years, yet I have been privileged to live through an era in which we have seen our first female Premier of Victoria, Joan Kirner, on the left, our first female Australian Prime Minister, Julia Gillard, second from left, and our first female Governor-General, Quentin Bryce, she's not there, who was the former Commissioner for Equal Opportunity. Yet, how much has really changed in that time? I want you to look carefully at the images of Joan Kirner, who was vilified for her spotted frock, and Julia Gillard, also vilified for her dress sense, her large rear end, and mocked with misogynist outcries and slurs on her marital status, of her being barren, that her father died of shame, as well as being accused with other females in the Australian Parliament of destroying the joint. Today we learnt that a menu item for a political fundraiser described her as a quail with small breasts, huge thighs, and a big red B star X. The star, I'm not pronouncing it. Successful women, it seems, have much to contend with. In the images on my slide, however, the two women are also portrayed as stereotypically incapable mathematically. Then there are the images on the right of the perfect, stereotyped female, pretty, sexy, although mathematics reveals that Barbie is unrealistically proportioned, and in being perfect, therefore naturally not interested in mathematics, or find mathematics hard, as Talking Barbie told us, and thus engage and therefore not be able to engage in the intellectually stimulating, and thus engage in the intellectually stimulating pastime of shopping. These images reinforce the need for my crusade to continue to monitor the status of girls and women in the STEM fields, that's science, technology, engineering and mathematics, as well as to further knowledge through research in this field. George Santayana's famous quote from his book Reason in Common Sense resonates loudly with what I'm to present tonight. And the quote is, "Those who cannot remember the past are condemned to repeat it." Alternatively, I could have turned to the genius of science fiction creators. I've always loved science fiction for its capacity to explore what it is to be human through the medium of futuristic encounters with aliens. Live long and prosper. The Back to the Future trilogy of movies comes to mind. If nothing else, we learn from them that what happens today is the blueprint of what's to come. So tonight, I briefly revisit the past and examine contemporary times in order to project into the future. The discipline is education and the field, gender and STEM. So we move on. No more script. Why gender and mathematics, science and IT? Well, here I am as a grade 4 student at MLC, and my parents sent me there under some difficult circumstances. Financially, we were migrants, or they were migrants to the country, hadn't been here very long, and my mother wanted to send me to the best. She believed that education was something that couldn't be taken away from you, and as survivors of the Holocaust, it was very important for them, my parents, for me to be educated. So I was sent to MLC, a Jewish girl at a Methodist school. And by the way, I'm very, very honoured tonight. There are two people here who taught me when I was in Year 7. My maths teacher and my English teacher. And let me tell you, they were very, very young. There's not many years between us. They were in their first year of teaching and we were in Year 7, so not too many years between us. And one of my school friends from that time is also here, so I'm very delighted with that. So MLC has lasting links through my life. Okay, Year 12. The typical clever girl at MLC did this combination of subjects. Or you did humanities, a classic humanities thing, and if you weren't that clever, you went to the business school. It's true. So there's my combination of then matriculation subjects. I came to Monash University as an undergraduate in the science faculty, and there you see my combination of subjects that I did, and something very interesting happened in second year. You notice I did physics in second year but not in third year. I picked up information or computer science as it's now known. What was that incident? I went into the laboratories. We had to do prac on rotation. It wasn't the big labs as they have in first year. And I came into this little room with this machine that I had to use. And I called in the tutor, the lab assistant tutor, and I said, look, can you please show me how to use this piece of equipment? And the man looked at me and he said, "If you don't know how to operate that piece of equipment, you don't belong here." So that was a bit of a jolt. And it ended up that I found a very nice young man also doing second year physics. He did the prac 1 week ahead of me, or when I was supposed to do it, because I never did any more prac. I copied his results. I became very good at manipulating the numbers and making it look a bit different. And that's how I got through second year physics prac. But that particular incident is something that made a mark, let's put it that way. I then went on to do a dip-ed here in this faculty and then moved on to be a teacher of mathematics, physics and computing. So you can see the three areas just continually stay together. Later, I was a sucker for every degree you could get. I finished a Bachelor of Education, later came back and did a Master of Educational Studies. My little thesis there was on gender and physics. Did a graduate diploma in educational administration. I thought I wanted to be a school principal. And then went on to a PhD in gender and mathematics. But let's look at me as a school teacher. All of you will recognise these. Any teacher of mathematics or physics, what's the first thing you tell your students to do? Draw a diagram. So I would have diagrams up on the board, or students would come out and they would draw their diagrams to illustrate how they had solved the problem. But then I would make a correction. And I got the same response from the students in the class. "Oh, Mrs. Forgas," it was Mrs. Forgas then. "Oh, Mrs. Forgas." I said, "I'm just trying to make a point." Who would you have assumed it to be without my little additions? The other thing I did, and this was then reflecting back on my school experiences, I would get the girls in my classes, and I only taught in girls' schools, to set up the physics equipment that they were going to use for their pracs. And Pam, who went to school with me, will verify this. We used to walk into the laboratories and everything was set up for us, and all we had to do was make the measurements. All the electrical circuits were all wired up, and all we had to do was push the button and measure the voltage or something like that. And I thought about that later, and I thought, could it have been that the male teacher we had for physics and the male teacher we had for chemistry, because it was the same in the chem lab, didn't believe we were capable of doing it, and it had to all be set up for us. I don't know the answer to that, but that was not going to happen with my students. Later as a teacher, and that's me. I was a young thing then. We do change. Thank goodness we don't see these changes happening until we look at photos. But I was working at Mentone Girls Grammar in 1981 and 82, and we had a Science Careers Week. And of course the focus of that Science Careers Week was to encourage girls to consider careers in the field. We had activities and we had speakers who were what we still term as role models. So females in particular career areas came out and spoke to the students. So there's the team of us, and I don't know if you can read it, but my T-shirt that we had made said, "I'm a live wire, I'm a physicist."
I'd love one of those.
Okay, so let's have a look then of the images of mathematics and science. So this is all the background to why I'm interested in this area of gender and STEM. I want you to concentrate on looking at the image, thinking about what you see, and you're going to tell me what you see and what's missing. I can take that away. Okay, so I'm going to ask you in a minute what you see and what's missing from these images. That's mathematics in the media. This photo of the 1994 Australian Maths Olympiad team. What do you see? What's missing? And I have to thank Natalie for this wonderful image. Believe it or not, she knows this young man. She worked with him at NEC, and I had a really bad image of this photo that was from a newspaper that I must have photocopied years ago and then produced as an image, and Nat saw it and said, I know him. And I said, can you get me a better copy of the photo? And she did. So that's a much better photo. All right, so anyone like to tell me, what do you see in those images and what's missing?
No girls.
No girls. Well,
One girl.
there's a little one hidden up here and another one hidden here.
Oh no, but definitely.
Okay, oh, in the other photo. Yes, you're right. Certainly the Maths Olympiad team, not a single girl. And I believe that not until 2001 was there a girl in that team.
The cute boys seem to be highlighted as well.
The cute boys. What about,
Yeah.
I mean, Asians are wonderful at mathematics. That's another stereotype that sort of abounds. But one group of people who saw this image picked out something that I'd never seen before, and that was that the three Asian boys were at a lower level than the Caucasian males. And somebody picked that up, and I thought that's a really interesting cultural stereotype, perhaps.
You'll have to ask the one who was in the photograph the dynamics of how the arrangement is made.
Yeah, well, I didn't have a chance. I only got this copy yet. Was it yesterday, Nat? Yeah. So I haven't had a chance to speak to him, but it will be interesting to know whether he was aware of that or not. All right, so we go on to my research. So perhaps you understand why I'm interested in this field. I honestly believe if you scratch beneath the surface of anyone's thesis or research area, there's a personal story in it. So you now know my personal story. So my research, and this is my one academic-ese kind of slide, talking about my epistemology, which is defined for you there as, and I will not turn around because it's rude, the nature of the relationship between the researcher, the knower, and what can be known. So it's what pair of lenses do you put on the research that you do? Well, I have two particular epistemologies, if you like, that drive me. The first one is an area called post-positivism, and it sounds, you know, a big word, but positivism is that terrible thing that people think scientists can be objective and unbiased in the work that they do. Post-positivists, however, say that's not quite right. You can't embark on research without some pair of lenses that you're wearing to look into the data. You can't be perfectly objective in what you do. That made me feel very comfortable. I like that. So context is important. The second thing, of course, is that I'm driven by feminism. And feminism isn't one thing, it's a collection of movements and ideologies aimed at defining, establishing and defending equal political, economic, educational and social rights for women. So whatever research I do, whatever it might be, I'm always looking at it through feminist eyes. And I also am an inquisitor of and I critique other people's research and asking questions from that feminist perspective. So I hope that's clear. Context is important. You can't be totally objective. You can aim towards that. There isn't one truth out there. There are multiple truths. And to get as accurate as you can, you need to have multiple perspectives coming in. But on top of that, the feminist glasses are put on. So what I'm going to present are some of the research findings, some of the work that I've done over the years. One of the things I really believe in, and I had it in my opening script, so to speak, is to keep monitoring what the situation is. So we're going to be looking at some participation rates in maths, science and IT. Another thing to monitor continuously is performance and we're going to look at performance in mathematics. Teacher expectations is something that has been of interest to me from my master's time. And so we're going to look at something about assessment in science. I'm going to touch on the topic of streaming and of course the area of stereotyping, which you've already met, but I've done some research in that area. Drawings of mathematicians, and we're going to look at a public survey that several of us conducted with an international sample. So we start with participation. So have a look at this graph. This is VCE Specialist Mathematics, the most challenging mathematics offered at the VCE level, Year 12. And this is the enrolment pattern from 2002 to last year, so more than a decade, 11 years. One of the things, let me just explain, because all of these graphs have the same. Along here it says within cohort percentage. In order to compare apples with apples, and not apples with pears, it's important to look at within the cohort, within the group of girls doing VCE and within the group of boys doing VCE. The cohorts are males and females. Why is that important? Because as it happens, and it's been a long-standing statistic, more females complete VCE than do males. So we've always got about 54% females compared to 46% males. It's around that figure. And so just looking at enrolment numbers does not give you the true story. So when you look at the percentage among the girls and the percentage among the boys, you've got something that is much better comparison. So what's happening here? Well, certainly our chief scientist and deans of science and others have something to worry about. There's no doubt there's been a decline for both males and females in the proportion of students taking specialist mathematics. But so too has the prerequisite disappeared, or has it disappeared as a prerequisite for any course anywhere in Victoria. Used to be a prereq for engineering at Melbourne, but when Melbourne went to its Melbourne model, there wasn't engineering anymore, and so it's no longer a prerequisite. So it's no longer needed. What I want you to have a look at is the gender gap now. So what we've got is a gap in percentage. So in 2002, we had a 7.4% difference, and in 2012, it's 6.2%. So it's decreased. Interpretation of that is, while males and females have both been dropping out, males have been dropping out at a greater rate than the females have. Okay, because the gender gap has decreased. It's the females, more of them, or a higher proportion of them staying on. So that's VCE mathematics. Let's look at mathematical methods, which is the middle one in terms of, supposedly in terms of challenge and difficulty, but it's also the one that is the prerequisite, if there is a prerequisite of a particular mathematics, this is the one. So again, there's been a decline for both males and females over that period of time. What's interesting here, and I have got a theory about this, but what's interesting here is that there's in fact percentage increase. So males are dropping out at a lesser rate, or females are dropping out at a greater rate than the males over that period of time. Around this time, 2007, the more sophisticated CAS calculator was introduced as mandated. All students had to use this very sophisticated calculator. And I have got some other data that appear to suggest that the dropout rate for girls may be related to the introduction of this more sophisticated calculator, but that's for another time. Further mathematics, supposedly the least challenging of the three, the one that is required for economics, business and economics, psychology.
Sorry, that is totally wrong. Sorry.
Okay, it's not a prerequisite, but it is heavy in the prerequisite mathematics for fields like business and economics. You don't agree, Anita? She's the expert in the field, so... Would you like to say why you're saying that?
Well, to me, it has no purpose, that mathematics, because it isn't a prerequisite for any courses at university level.
No, it's not a prerequisite, but there are a lot of courses...
You've been commenting on. So
No, this one's not a prerequisite, but it's preparation for, because of the emphases are not calculus-based, not heading towards the science courses, but the emphasis within the course is more geared towards statistics and probability. You don't agree with me?
no, but well...
It's not a prerequisite.
You can't get into any commerce or economics course with that mathematics, so I don't know what the purpose of that would be then.
I think we have to, I'm prepared to look into it, but I don't think, I think the prerequisite is A, mathematics.
No, sorry.
It says maths methods to get into business.
Definitely.
Okay. All right, I stand corrected.
I need to educate you, I think.
Okay. But certainly where there are courses that say A mathematics, and there are several of them that do, this one is enough to get in. In fact, my understanding is now that even the science faculty here at Monash only says A mathematics and doesn't actually require maths methods. It's preferred, it may be recommended, but it's not the one that you need to get in. But I take what you say on board, Anita, and I'll look into it. And I apologise if I've been giving misinformation, but that is certainly my understanding. Okay. Well, be that as it may, we've also see here huge increase in overall in the 11-year period of the number of students taking that subject. In fact, from 40-odd% up to 60% of VCE students, both males and females, taking it. But you've got, again, a slight increase, suggesting that males are taking it up at a slightly higher rate than females are taking it up. But we do have to be proud of the fact in Victoria that a huge number of students do complete a mathematics in their VCE years, and that's a big positive out of all of this. But the differences in the maths methods, then Anita, with that one, going back to that, that's telling then for entry into business and economics courses. If what you say is true, then
It's definitely true.
Okay.
We'll have a little bit and I'll tell you tomorrow.
Okay, that's cool. But that will then have an effect on that
I
too.
think it'd be interesting to look at the number of students who take more than one maths.
Yes.
And I think you'll find that a lot do methods
And further.
They know they're going to maximise their ATAR. But it doesn't mean that they're taking further to follow it through in a course sense.
No, I don't think I was saying that. I was saying that about the content of the course is more geared, it's not geared for a scientific pathway. That's the point I was trying to make. Okay. Let's have a look at VCE participation in the other sciences and IT courses offered at Year 12. And these are all 2012 data. So across this first one are all VCE enrolments, and in 2012 it was 53.1% female. So I then draw across my graph here what I call the equity line. That is, you would expect 53.1% of females in order to have full representation or equal representation in the subject. So what do we see here? Well, here are the subjects where females are underrepresented. Very slightly in chemistry, it's very small. Huge, big gap in physics, big gap in the two IT subjects in particular. In fact, that second one, which is called IT software development, females only represent 5.1% of the enrolment. It's a small enrolment, it's not a big enrolment. It's only several thousand, I think, 2,000 something. But females only represent, they were in 2 digits and not 3. Not even 3. So there's clearly a gender divide in the VCE enrolment patterns in science and IT subjects. Where are females overrepresented? In the biological sciences. We've got biology itself and psychology, the 2 areas where females are greatly overrepresented. Let's move on then and have a look at Monash University 2012 percentage female enrolments by faculty. That's the left-hand column in in the graph. The right-hand column is higher degree by research female proportions. Okay, so what do we see here? Well, again, Monash total enrolments. Females make up 56.3% of Monash's total enrolment. That's in all courses, including HDR. And in terms of HDR, though, it's 53%, so it's a little bit less. Okay, but females are, in terms of pure numbers, are more represented in at the university. So here's my equity line across the 56.3%, and let's have a look what we see here. Slight underrepresentation of females in business and economics. Huge underrepresentation in engineering, information technology, and very slightly in science. Now, science, of course, is compounded by the fact that you have the biological sciences and the physical sciences, and I couldn't get the data to disaggregate that. So it's balanced, possibly in the same way as we saw with the VCE enrolments, by sub-discipline within science. Very interestingly, those 2 green arrows show that in terms of HDR proportions, higher degree by research proportions, in those 2 very poorly represented by females faculties, engineering and IT, there's a higher proportion of females. They're more representative there than they are in the overall proportion of students in those faculties. And that's really interesting. Why that might be would be certainly worth exploring. This next slide is the Monash University academic staff profile. And I'm doing all of these for a purpose. Okay, so here's the overall, I've got staff profile by faculty and staff profile at level E or professorial level in the university. So by faculty, females now overall in the university are 49.9%. We've almost got equal representation of males and females on the academic staff at the university. However, when it comes to professorial level, 25% overall in the university. So let's have a look at the equity line at 50% basically this time. Females underrepresented in art, design and architecture, business and economics, engineering, much more so, information technology and science. But look at those professorial levels. The women are not there at the top. In 2009, the gender equity strategy within the university wrote that the faculties with the lowest percentage of academic staff who are female are information technology with 27.5%, science with 26.8%, and engineering with 14.1%. So in fact, things have got a little bit better since 2009. Again, information technology stands out as the one faculty where at the professorial level, women are at a higher proportion than they are generally within the faculty. So that's another interesting thing. What's going on in infotech? But none of the other faculties is that the case. So we've seen a pattern of participation, lower female participation at the school level in the sciences and IT areas. Clearly, when it comes to tertiary level, the same pattern, and when it comes to representation at the academic level in the university, it's not to be unexpected that females are underrepresented in those same fields. So let's have a look now at performance. I only have one slide for performance, and this is, you know, sort of a very hot area, NAPLAN results. Okay, NAPLAN results, and these are the average scores for males and females in years 3, 5, 7 and 9 for the entire period, the whole time period that the NAPLAN has been administered from 2008 to 2012. Again, what's the pattern here? Well, it's not hard to see that in each year from 2008 to 2012, and at each grade level, 3, 5, 7 and 9, the boys are outperforming the girls on average. So the blue line is the boys' performance and the red one is the males' performance.
So, Helen, are we looking at numeracy?
Yes, sorry. Thank you for the correction. This is the numeracy, not... Oh, if we had a look at the literacy ones, it would be totally reversed with much bigger gender gaps between them. The girls are just streaks ahead when it comes to, I think it's the 3 literacy areas that are measured. The gender gap in all of them is in favour of females and much wider than they are here. But it certainly does not seem to be much concern, and I know it's got to do with people not valuing NAPLAN, and many of us don't think it's the way to go forward to learn about assessment. But the community and government think it's really important. And as researchers, it gives us a huge database to work with in which to explore a whole lot of issues related to performance as measured by that test. As measured by that test. I repeat that, as measured by that test. Okay. Let's look now at some explanations for gender differences in participation and performance. They have been the 2 areas since the 1970s that have been of interest and attention of researchers in the field. And Gila Leader, who's here today, who is my PhD supervisor as well. So Gila, it's an honour to have you here too. And we continue doing research together. In 1990, put together this synopsis, this explanatory framework for gender differences in mathematics, performance and participation from a range of different theoretical perspectives or explanatory frameworks that were around at the time. So this is a synthesis of all the factors that various different models had put forward to explain why there were differences. So this is an overview of a whole lot of different models. So you've got 2 main areas here: variables related to the learner, variables related to the environment. And so you see things like sex role congruence, which is whether you feel as an individual, if you're a male, let's say you're a female, whether you belong in a male-dominated field. That's the sex role congruence, and we're going to look at some of that. You've got a whole range of different things: confidence, perceived usefulness of mathematics, to what reason, attribution style, what reason you give for succeeding and failing in mathematics, and so on. Over here, a whole lot of factors, and I've already touched on some of them, such as the media, cultural expectations, parents, socioeconomic status is a big one, and within schools, teachers, textbooks, curriculum, assessment. There's a whole lot of factors within schools too. So there's some of the things that people who are in the field of gender and maths and science, IT areas, these are the sort of variables that we explore. Some, of course, postulate that there are biological or genetic explanations for male superiority in mathematics. So I ask, what's the evidence for the claim? Well, to date, no gene has been found that has any relationship to mathematical capability. One of the things that's often talked about is females' lower spatial visual skills, but they're now postulated to stem from prior experience and not genetics, and they can be overcome with training. It doesn't take much. There's been research on that, a little bit of training when it comes to those rotating shapes around and stuff like that, and girls can do it as well as boys do. So it's prior experiences, childhood experiences. I want to remind you here about Lawrence Summers, who was the president of Harvard University, who unfortunately for him opened his big mouth when asked the question about why there were fewer female science academics at Harvard, when he included in his explanation that there really were possibly some genetic factors also involved. Well, that resulted in a huge outcry in the United States, and the man did lose his job. But another thing that I found was interesting, that during his time, the number of academics, female academics appointed to Harvard dropped from 36% to 13%. So 36% before he started and 13% during his time. However, there is evidence to refute the claim of a genetic factor, and actually supports very strong cultural and socio-economic explanations. And here I have, and I know this is a hard one to see, but I wanted to put the whole thing up. These are the TIMSS results, and there are 43 countries. The Trends in Mathematics and Science Study, TIMSS, from 2008, and this is the graph that's produced that shows gender differences in increasing difference. Now what you need to focus on is this line down the middle. The line down the middle is no difference. If the little bar goes to the right, it means that the males scored higher, and if the bar goes to the left, females scored higher. So in fact what we have from TIMSS at Year 8 in 2011 was that in some countries, females are outperforming the males, and if this bar is coloured in as opposed to empty, it means that it's statistically a significant difference between the males and the female scores. So you have some to the right and some to the left. If it was genetic, how do you explain that? So we can provide evidence that suggests that there can't be a genetic factor unless people in some of these countries are their genetic makeups are different from the others. But what is interesting here when it comes to cultural issues, and this hasn't been explored yet, is these countries at the bottom, down here with the biggest gender difference in favour of females, are some of the Muslim countries that participated in TIMSS. So it's really interesting, why is it that in those particular countries the girls are doing so well? I have to add that overall the performance in those countries is pretty low. It's from a low overall ranking. They're at the bottom in terms of the rankings, in terms of overall performance by country. But interestingly still, within those countries, the girls are doing so much better. So it strongly suggests some sort of cultural cultural factor, and as yet unknown. Okay, let's move on to teacher expectations. Many of you will be very familiar with this very famous research study, which unfortunately anyone who applied for ethics clearance to do it today would be rejected. It was a study in which teachers were provided with information, false information about some students in terms of their capabilities. Okay, so you can imagine coming into Year 7, a new school, and the teacher being told this was a shining star, shining light in primary school, and this one didn't do so well, and so on. And what they found, of course, was that when teachers expect students to do well and show intellectual growth, they do. When teachers do not have such expectations, performance and growth are not so encouraged and may in fact be discouraged in a variety of ways. So kids live up to or down to teachers' expectations. I would love to be able to do that again. I'm sure many of us would really like to do it again.
I have to sign the form.
Yeah, that's right. Okay, so as part of my master's, I did a thesis following the research of someone in England, Margaret Goddard Spear. And I'd been reading about gender bias in assessment, that teachers, this teacher expectation that in the sciences, and it was in science education or in physics in particular, that because teachers would expect boys to do better, they will. And so Margaret Goddard Spear actually used teachers, and the thing about this approach or this particular method of getting the information is that you use real samples of work handwritten by kids, and you put at the top the same item, the same piece of work, sometimes has a girl's name on it and sometimes has a boy's name on it. And you give it to teachers to assess, and in my case it was pre-service teachers, and have a look whether the fact that it's a girl or a boy on that piece, identical piece of work, has been assessed differently on average. Well, Margaret Goddard Spear found that they did. I also actually didn't find significant findings, but there were trends. So there were 3 pieces of work from each student. And teachers had to mark those 3 pieces of work for 6 students, 3 said to be girls and 3 said to be boys. So this was a logistic problem, nice mathematical one, to make sure that, you know, people had different combinations of the girl-boy. So what did I find? I found that on the test, one of the 3 items was a test. There was no difference in the scores for girls and boys. In other words, on this supposedly more objective measure, it was a bit harder to mark in any way other than have a consistency in it. And this was even with pre-service teachers. And they were given a marking guide for it. When it came to the laboratory report, the boys were scored slightly higher on average than the girls. When it came to open-ended responses, written responses, the girls were scored slightly higher than the boys. There were 3 other questions, or a few other questions that accompanied this thing, and the first one was about judging the neatness. And we all know that girls are neater than boys, don't we? And so the identical piece of work was rated on neatness, and when it was a girl's piece of work, it was rated somewhat on average neater than when it was a boy's. And final question was, and this was Year 10 work, so students would be choosing whether to continue with science or choosing whether they'd go into particular sciences at Year 11 or not. So the pre-service teachers were asked, on the basis of these 3 assessments, would you recommend that this student continue with Year 11 physics? And what was really interesting here was that when it was at the top or the bottom, really bright, high-scoring kids or low-scoring kids, there was no difference. But when it came to those middling kids, the ones who were moderate assessment level, that's when it was recommended more strongly that the boy should continue with physics than with the girl, than if it was a girl. So same work, identical work. When it was a moderately scoring student, the boy was more likely to be considered to have the potential to go on to Year 11 physics. So I'd really like to know if that kind of bias is still there. Streaming for mathematics. In Victoria in the 1980s, and when we had that big revolution, Ministerial Report number 6, Blackburn Report, all of those things, a real era of big change in curriculum in the state. There was a newsletter came out from VISE, the Victorian Institute of Secondary Education. It was known as ADVISE, very clever. And Jeff Emmett wrote in that one of those issues about streaming. And that's what he wrote, that streaming and setting, whatever terminology you want to use, if we are to believe the research, are unsound educational practices, and all educators should strive to minimise and eventually remove their influence so that schooling recognises and promotes the gifts all young people have. So I went about in the early 2000s, or late 2000s I should say, collecting an online survey, responses of teachers about streaming in Victorian schools for mathematics. So there were 44 teachers responded. Small sample, I know, but it's very hard to get teachers to do things, so I was very grateful for the 44 who did this rather, probably too lengthy, online survey. So they were asked the questions, is there a form of streaming in grades 7 to 10 in your school, and do you agree with the school's policy? So we had 80% of them saying yes, there was streaming in the school, and of those, most of them agreed with the school policy. The people who said no, and there were only 4 of them, 3 disagreed. In other words, they didn't like the fact that there wasn't streaming in the school, disagreed with the school's policy of not streaming. So in other words, there was very strong support for streaming. Question is this a gender issue? And I would argue that it is, based on the teacher expectation data and general findings in that area of teacher expectations with respect to girls and boys and the sciences and mathematics. So I think it is an issue. Who will be selected in, especially if it's a borderline child in a co-educational school and there's a boy and a girl who are about the same, who's going to go into stream A and who's going to go into stream B? So I think there is a gender issue there. And just to show you how prevalent streaming is, at what grade levels, I did ask them what grade level the streaming started in the school. 37% at Year 7 already. So we're deciding where students' futures are going to be. A third of them at Year 7, up to 78% at Year 10, which Year 10 is kind of more understandable, but Year 7, 8 and 9 are a bit of a worry. I've got a PhD student who's, no, she's not here today, but she's going to be looking into this, so that's really quite exciting. Okay, let's look at some things to do with stereotyping in mathematics. Have a look at the images here. These are the stereotypes. Asians are good at maths, boys are good with the calculators and technology, and girls, well, you know, 1 + 1 = 7. That's a bit of an exaggeration, but I'm trying to make a point. One of the things about stereotypes that is worrying is that people actually believe that they're true. So I asked students to draw a mathematician, and these were again pre-service teachers, and the number is there, 41 of them. And 26 out of the 41 drew males. And I'm going to show you some of these images in a minute, but I want you to reflect back when you see them to the images from the media. I mean, I don't know if you noticed Robin Williams in the Flubber film and Julia Sumner Miller. Yeah, right. So you've got the mad scientist with, as you can see, the characteristics. 18 out of 26 had glasses. There were beards and moustaches, bald briefcase teacher, computers or calculators on them, academic hat, and crazy aspects such as their hair. So they were the characteristics of the males. And here we have, I'll show you some diagrams of the females and the gender-neutral characters. And there were 8 gender-neutral, and one of them, I'll point out, was very lovely. It could be anyone. Oh, don't I love that pre-service teacher. But notice that most of the women are clearly teachers with glasses. Well, we can't help that, can we? And the gender-neutral characters there. I mean, I could argue that this is probably a male, but I was generous in deciding on gender neutrality. So, you know, this one, sort of slightly crazy hair, but, you know. So they were the images I got in 1999, and repeating that in various other years, you still get the same images. And if you ask children to draw the mathematician or the scientist or an IT expert, Amber's not here, did it as part of her PhD, you get the stereotypes drawn. But that's what they see on television, in films. We're very good at reinforcing stereotypes. Okay. This is a really interesting study that Gila, Hazel, who's here as well, and I conducted. It's about 3 years ago now, Gila. I think we did the initial survey. We used Facebook. We use Facebook to recruit participants. You put a little advertisement on Facebook, and when people click on it, they're taken to the online survey. So it's a really exciting adventure for us. The first thing I'm going to show you here is we had 2 separate surveys. Later on, after our success with the maths one, we decided we would change the wording from mathematics to English, identical items. And there were 2 questions that were in common on these 2 surveys. And so we've got totally different cohorts of respondents. And I want to show you the similarity in their responses. Those were the 2 common questions. Who are better at using computers, girls or boys? Who are more suited to working in the computer industry, girls or boys? So we had 2 common items to help us judge whether we had nice samples or not. And this was one comparative question. Who are better at mathematics? And the other survey said, who are better at English, girls or boys? So let's have a look at the common question number 1. Who are better using computers? Well, there you are. In terms of the height of the columns is all you need to look at. Boys are better, girls are better, and the blue bar are the people who responded to the maths survey, and the red column is the people who responded to the English survey. Almost identical distribution of their responses. A lot of people said the same, and that we're very pleased. There's no difference. However, if they do have a gendered perspective, both groups, both cohorts, said boys are better at using computers. Well, what about who are more suited to working in the computer industry? Again, if they had a gendered perspective, clearly, and again, almost identical responses, response distribution, boys are more suited to working in the computer industry than girls are. Again, lots said the same. But this is the telling one. Who are better at mathematics? Who are better at English? Okay. Remember, the red respondents are the red bars, the red columns refer to those responding to the English survey, and the blue ones are to the maths survey. So who are better at English? Girls. And who are better at maths? Boys. If people had a view that there was a difference between them. Oh, sorry. Again, a lot of them said there's no difference. But it's striking that for English, the belief out there is that it's girls better at English, and the belief out there is that it's boys are better at mathematics. Two totally different cohorts. We went beyond Australia, and we had responses from 81 countries. Unbelievable. It was so exciting. I mean, can you imagine sending research assistants out to 81 countries to collect data for $10,000, which is what the research cost us? It was just an amazing way to recruit from responses from around the world. So 784 people altogether responded, and this is now only about mathematics. And you see the male-female response rates there. But there were 9 countries from which there were more than 30 responses. So statistically, it's a nice number to work with to look at comparisons. So here we are. Who are better at mathematics? I'll read out the countries: Canada, China, Egypt, India, Israel, Singapore, United Arab Emirates, UK, and Australia's over on the right. So what do we see here? Who are better at mathematics? Well, in 5 of the countries, and Australia's got the double arrow because it was identical, boys and the same. The green means the same. People seeing no difference, and when it was a majority response, or not necessarily a majority, but the most frequent response. So there were 5 countries there. However, if you compare in each of the countries, if people said there was a difference, girls or boys better at mathematics, there's a consistent pattern around the world. Boys. China, of course, is the big standout there. Nearly 70% saying boys and very, very few saying girls. But there is variation across the countries. Again, cultural factors seem to be implicated here. What exactly they are, yet to be identified, but we have a consistent pattern in those 9 countries around the world. And when we looked at all 784 responses, it was the same pattern. So clearly these 9 countries dominated, but including the other countries where we might have had 1 or 2 responses from a particular country, we get the same pattern around the world. So this is telling us something, and the United Nations Commission for the Status of Women, when I went to New York, this was something that had been identified too. So what are our ways forward? Well, I want to talk very briefly about a research project I've been involved in. It's a linkage grant with an Australian Research Council linkage grant with my colleagues at other universities, and the other 3, other than me, are in faculties of IT. So Julie Fisher at Monash here is one of those professors in the Faculty of IT. So it's a linkage grant. It was a school intervention program running for 1 term in each school to try to encourage, to build girls' skills in IT and confidence, and to increase their motivation and interest in pursuing careers in the field. We're still analysing the data. The results are a bit mixed. Some schools it worked better than others, and in some areas we didn't achieve our goals or our aims with the project. That seems to be the pattern that's coming through. But what seems to be very critical here is the teacher. And I think we all know that anyway. The teacher was assumed to be enthusiastic and wanting to teach this subject. The reality of schools is that sometimes the teacher who had a slightly lighter load was sent in to run the Digital Divas intervention class. So, as I said, mixed results. But interventions, as a way forward, we still need some form of intervention, whether it is in the classic form that it has been in the past, and this particular intervention was a pretty traditional model of intervention. There are other ways that we can intervene to raise girls' particularly awareness of issues to do with math, science and IT. A second way forward, what parents do, what toys they buy for their children, what experiences they give their children before they come into schools can affect a whole lot of things, as we know, in the educational realm. But it can also start developing particular beliefs about what is appropriate for a girl and for a boy. So I was pointed to this website, contrasting Barbie that you saw before. Lego has made an effort with this series of female minifigure set showing girls in all sorts of fields of science. So from our astronaut, bird keeper, I can't tell what all of them are.
Look at the stereotype.
Yeah, astronomer, and so on. Another way forward, and I've got to go and click this one on. I will put this on for you. Some of you may remember it. It's working before.
As parents, we are often guilty of pigeonholing our daughters. Traditional roles, traditional jobs, traditional school subjects. But today's world is crying out for girls in all kinds of technical and scientific careers. By doing maths and science to BCE, girls increase their career choices by 400%. Discuss the options with your daughter so she doesn't stay pigeonholed for the rest of her life. Maths multiplies your choices. Call us for more information.
Okay, some of you might remember that from television in 1989. What was interesting is that it was the Department of Labor, not the Department of Education, that funded this particular awareness-raising campaign. It was called Maths Multiplies Your Choices. It was the Department of Labor wanting skills shortage, so let's call in the girls. But it had an amazing impact. If you read the reports on what happened afterwards, the following year, 1990, maths enrolments at Year 11 skyrocketed for girls. Well, skyrocketed, a huge increase. Bigger than any increase that had been seen ever before. It was so successful, parents were aware of this thing, so successful that it wasn't funded the following year. We've done the job now, we've solved the problem with, you know, girls and maths. That's it, no more funding. So it's really interesting, it was found that that television ad, and anyone who was around at that time, don't pigeonhole your daughters, stays with you. I certainly remembered it, but then I was aware of those things, very aware of those things. But it was a very successful campaign. So the media are very powerful. Using the media to get the message across is really powerful. For example, the programs show with women as vets has made a big difference to enrolments in veterinary science. We have women being shown as doctors now in many programs, the medical type programs. There are many, many women doing medicine now. But you have a look at those programs, even the current ones, where they've got the token, well, not token, actually central women, like Abby, the goth in Criminal Minds, and she's the computer whiz in that program, but she's a goth. You've got to be a bit weird. And then there's Garcia in NCIS. She's always dressed in pink. She's a bit overweight, and she's the computer, and she wears glasses, and she's the computer whiz. So the images that are portrayed are not of normal women. And I don't know if the message is getting across that you can do it. You can do it only if you're a bit strange. Whereas in the medical programs and so on, they're quite normal, everyday people, not the stereotypes of being nerds or weirdos or whatever. The boys, by the way, in the IT crowd, anyone seen that thing? Talk about nerds in the basement with their, and they're males, but they are the stereotype of the IT nerd. So, just to conclude now, you might remember what Alan Jones had to say about women destroying the joint. My second venture into Facebook, I was shown how to do this. There was a Facebook site, do you call it a site? Destroying the joint. And Ilana pointed me to it. And some of these images come from there. So, do we need to burn our bras again? Do we have to go back to that historical era? I quite like this one, Rosie the Riveter, who was a role model for the second wave of feminism in the 70s and 80s. But this one's obviously a doctored photo, but I love it, with these working class men, dismantle patriarchy, sexism as a social disease. We need men on side as well as women, and here we've got another one. And this is a book that came out by Penny Wong and a whole lot of other people in response to the destroying the joint comment by Alan Jones. So hopefully we don't have to do that, and this is having a go at Alan Jones himself. We regulate the women, but we don't need to regulate pollution. So what are our priorities in life? So on that note, I thank you very much for your patience, and thank you.
Well done. So it's my pleasure to thank Helen for presenting tonight, but before I let her go, I just think it is an interesting thing that you have two of her teachers, a school friend, Gila, who's put so much in as a colleague, supervisor, a mentor. There is something really important about education and what people are prepared to do and why they do it. And here, for those of you who've put in, it's a proud moment to have someone like Helen stand in front of you as a professor in a faculty of education and have an opportunity now to give back. So I thank you on behalf of Helen. I'm sure she will thank you herself, but it is a wonderful thing, and it is the way that it ought to be. Helen, you demonstrate tonight what it means to be a professor, why you are a professor in a faculty like this, and we're very proud of you, and it's a pleasure to have you here. Thank her once again, please.
Thank you. One who
I have to thank you for nominating